What is up, Algebra 2? Grab your reviews. This isn't going to be answers, but it's going to be a lot of the first and second step for a lot of these problems here. So we'll start with number 1. We're going to turn it into, we're going to keep it as a fraction, but we're going to put this radical sign on top and bottom. And what we notice is whenever we have this radical in the bottom, we don't want it there. So I'm going to need to multiply by that radical. But since we have cube root, I can't just multiply by the cube root of 5 once. We have to multiply by the cube root of 5 2 times. Because if we have 3 things that are all cube roots, it's all going to simplify out to be just 5 in the bottom. So go ahead and go through and multiply this when we know the bottom's going to simplify to just 5. So the top part, we're going to have to multiply these insides and then see what we can take out. If we look at number 2 here, we need to break these numbers down. We've got different radicands, and they need to be the same in order for us to subtract things. So if we look at how we can break down 16 and 54x cubed, we get trees that look something like this. And we need to see what we can take out. So since we see cube roots on both of these, on 16 we've got 3 2's that we can take out. And we also have my x cubed, that means we can take out an x there. On 54, we have a group of 3 3's, and we also have x cubed that we can take out. And so after we take these pieces outside, we get something that looks like this. So go ahead and multiply those out, simplify them, and see what you get. Next one, let's go down to number 6. If you remember your rules, if you have an exponent and we're multiplying by another exponent, we're going to end up adding them. So think about 1/2 plus 5/2. We're going to end up with 7x to the 6/2, and you need to go simplify that from there. Then for things like 7 and 10, it's just a distribution problem. We need to do your 4 times 5 gives you 20. 4 times negative root 5, so negative 4 root 5. And then distribute your other terms, and we're going to see how that whole thing simplifies down. Now with solving each equation on the next page, we're solving for x in every one of these. So let's take a look at number 12 here. If we want to figure out what x is, I'm going to rewrite it first. So hopefully you remember that anytime something is raised to a 1/2 exponent, it's the same thing, square root of negative 3x plus 18. And we know to get rid of a square root, we're going to have to square both sides, which gives us negative 3x plus 18 equals x squared. And then now you can move over your 3x and your 18. And now we'd have 0 equals x squared plus 3x minus 18. And now if you go through and finish this, you'd have to factor that to see what your x values are going to be. So you'll have 2 answers for that one. And the rest of these are solved pretty similarly. If you remember PEMDAS, that's how we'd solve regular order of operations, but we're doing these backwards because we're solving each for x. So if you talked about SADMEP or SADMEG, always do what's added or subtracted first. So on example for number 11, since you have a negative 6 on this one, we'd have to move that. For things like 14, there's nothing added or subtracted that we can immediately get to, so first you'd have to move that 7. So that's where your divide and multiply comes into. So as long as you follow those, you'll be okay for the solving. Now let's take a look at 16. If we want to write something in a simplified exponential form, this one's similar to what we did on the first page, so we can think about what we take out of 16. So we know 16 is 4 times 4, and then you've got a pair of 4's right there. So if we take that 4 on the outside, now we have 7 times 4 on the outside, and it leaves your y. And we know it's just going to be 28. And then if we have y as a square root, we can write that as y to the 1/2, and that would be your answer for that one. So there's a free answer. 17 is a little bit tougher. If you have 2 fractions that are subtracted or added, we need to have a least common denominator on the bottoms here. So since they're both very different, we need to multiply each denominator by the other one. So on the left side, we'll have to multiply by x plus 1 on top and bottom, because that would make a common denominator for us. And on the right side, we got to multiply by your x minus 3. And so now for your least common denominator, we know it's going to be this bottom portion here. So what you have to do is multiply through these top pieces so you can subtract them. And another thing to think about is your excluded values. If we pay attention to what's in the denominator, the only thing you can't ever divide by is 0. And the thing that would make those denominators 0, so like if I had x minus 3 equals 0, if x equals 3, that would make the denominator 0. So x can't be 3. That's an excluded value for this one. If we look at the other one, x can't be negative 1, because if we had negative 1, negative 1 plus 1 gives you 0, and we can't divide by it. So in addition to your answer, we need to also express the excluded values. Moving on, next page. Vertical and horizontal asymptotes. If you remember your graphs, anytime that you've got a line that's approaching something that curves sharply away, we know that that's where we'd have our asymptotes at. So what you need to do is graph this on your calculator and see where those lines are curving sharply away from. Those would be your asymptotes. The next one, the keywords here is varies inversely. If you remember your inverse variation equation, we know it's y equals k over x. But instead of y varying inversely as x, we have current and resisting varying inversely with our constant of voltage. So the equation you'll need for that one would be current equals voltage over resistance, because current varies inversely with resistance. So look at what you can plug in there to get your answer. Now for the next one, if you've got solving, there's a couple ways we could do this. We could make common denominators, or you could also do cross multiplication. If we did cross multiplication with these, 48 from 6 times 8 equals x plus 1 times x plus 3. So you'd have to multiply that out, probably factor it to get your answer. And again, we'll notice that we have an excluded value, because on the bottom here, x plus 1, if we had an x value of negative 1, it would make it 0. So that's why we also cannot have negative 1 for an x value. So that's your excluded value. You'll see that pop up on your test. So make sure you know excluded values, things that we can't put in the denominator that would make it 0. Those are excluded. Now 23 is a little bit tougher problem. It's going to tell us that two people are doing yard work. So Mary and Sam are doing yard work. So if you think of this as Mary does yard work and Sam does yard work for the total amount of yard work done. If you think of it as if Mary does it by herself, so one Mary, it takes her 3 hours. And if Sam does it by himself, that's what we're trying to figure out. So the time for Sam to do it by himself, and if they did it all together, that would be 2 hours for the job. So you'll have to go through and solve this and first come up with your least common denominator. So if we think about 3t and 2, the only thing that they have in common would be 6t. So we need to turn all of these denominators into 6t, and then that would change the top and help us figure out the amount of yard work they'd have to do, or the amount of time it would take Sam by himself. For these simplified ones on the next page, we're going to need to think about how these exponents all cancel each other out or combine together. One thing to remember, if you have a negative exponent, it's going to go on the opposite side. So the b negative 5 is going to end up coming down here, and we know that we'll have b12 on the bottom there. So then you'll have to figure out how your a's combine, how your c's combine, where your 6 goes. But that should hopefully get you started there. 25, look at it and first factor your top. So look at your term on the right. What multiplies to give you 7 adds to give you 8. And then if we think about this term on the bottom, we have a squared minus 7 squared. Since you have a difference of squares there, we know that that's going to turn into a plus 7 and a minus 7. And you'll probably see it cancel out with something on top, or divide out. Next one, simplifying the expression. Try to factor these out first, see what you get, and remember, we have to make the denominators the same in order to be able to subtract two fractions. For 27, again, factor to break it down first. You have a difference of squares. If you think back to 25, a squared minus 49 is very similar to the top and bottom portions here. So factor those first and you'll see it simplify nicely. Number 28, just because it's a fraction and a fraction, don't let it scare you. We're just going to rewrite it here. So I know that I have negative 12CD over 9XW and divided by 15C cubed over negative 6W squared. So this is probably the form that we've seen it a little bit more frequently. So if you have something like this, if we change this to multiplication, we need to multiply by the reciprocal. So change this to multiplication, flip the right side, and then you'll be able to simplify it and solve it out. On this graph problem, go ahead and put that in your calculator first so we can get a good idea for what this graph looks like here. And then again, asymptotes is where that line approaches, but it sharply curves away. So whether it's a vertical asymptote or if it's approaching something and it sharply curves away and we have a horizontal asymptote, that's what this is asking you to find. So graph it and look to see where those asymptotes are at. These had a little bit of a misprint, so please make sure that you fixed them. For number 30, instead of negative 8x9, make sure you know that it's negative 8x to the 9th power plus 6x minus 7. So if it asks us for degrees, degree, we're looking at exponents. So we know we've got a 9 here, there would be a 1 here, and our biggest degree would be a 9, so that's what we care about. So we know that since it's degree 9, pretty much everything cancels out, and the leading coefficient is negative 8 because in front of our x to the 9th we have a negative 8 there. Very similar for 31, 32, and 33. If you remember, a 0 is the same thing as a root or an x-intercept. So if you graph these and look for your roots or your x-intercepts, that will give you an answer. If we look at something like 36 and it says divide f of x by d of x, this is something we haven't done in a while, but if we take f of x here, we've got x squared minus 2x plus 3, and we're dividing d of x. So we're dividing x minus 4 into that. So if you think back, this is where we see we have x and x squared, so x times x would give me x squared, and I need to multiply back there to see what's left. So x times x would give me x squared, and then x times negative 4 would give me negative 4x. And so we're going to subtract to see what our remainder would be. Well, the x squareds cancel out, and a negative 2 minus negative 4, we know minus minus makes positive, so we have 2x. Bring down the 3 and we repeat the process. X times 2 would give me 2x. And now you multiply back through. 2 times x and 2 times negative 4. Well, 2 times x would be 2x. 2 times negative 4 would be negative 8. Subtract those again, and you end up with positive 11. So if we look at our answer choices, we know that we're going to have an x plus 2 in there. So we can cross off A and C. And then in B, notice we have a remainder of 8, and in our problem we have a remainder of 11. So that makes my answer D. Back to logs and exponentials. We just took a test over this, but we'll go through a couple of these to refresh. First thing is on 46, we can set this equal to x. Since there's nothing written there, we can just assume that it's x. So if we write this, remember that your 5 is your base, whatever that little number is next to your log is always your base. So as an exponent, we'd have a big 5. And in log form here, our base is 5, and our exponent part would be your x, or whatever your log is equal to. So we have 5 to the x equals whatever's left, 125. Another way you could think of this is if you remember I love logs. If your equation is set up as log 5 125 equals x, I love logs, you always start at your base. So my base is 5, and you hit the x, and then we end up with the 125. So there it makes your heart, so we know you start at your 5, we touch the x second, and then we end at whatever is in the middle there, so 125. So that would be an exponential form. Same thing for number 45. If we're solving things, 47, 48, use your flow chart for these. We've gone over these several times in class, so please pull out your flow chart. That will help you with all of those problems. With 54, we have a population that's increasing. This is your equation, A equals P1 plus or minus R raised to the T. So if you think about increase tells us that we should be using your plus sign here, and you're going to plug in your percentage for your rate, your people, goes on either side there, and you'll go through, solve that one. 55, a little bit different equation. If you see compounded continuously, our equation here would be A equals PERT. So a little bit different. We just have your E. You also need to add that this is after 5 years. We forgot to put in 5 years for this. So that would be your time. 3.5% would be your rate, but remember any percent is out of 100, so if you divide 3.5 by 100, we know that our rate would be 0.035. Next. This one's very similar to a couple problems ago. So use your equation there, except we know our new amount that we want is going to be 600,000. We start with 420,000 and 1 plus or minus R raised to the T. So think whether or not you use plus or minus. Add in what you, or now we're solving for our T, so it's going to be logs and exponents to solve this one. Moving along. Transformations, if you remember, K moves your graph up and down. K goes up and down. H moves your graph left and right. And then A stretches and compresses. But nothing in here is about stretching and compressing, so you don't have to worry about it too much. Next one, graphing the function and name the parent. If we graph these points right here, we have -3, 0. We got -2, 1, 1, 2, and 6, 3. So it's somewhere right there. So if we connect all these, if you think about your parent functions, it's been a while, but this one's going to be y equals square root of x. So remember, your parent functions can be anything like y equals x squared, y equals x cubed, y equals the square root of x. So if you need to remember what these are, put these in your calculator to see what the graphs look like to compare what your graphs look like. Part 6, domain and range. Most important part of this, remember that domain is your x values, and we always measure it from left to right. And range is going to be your y values, and we measure these from bottom to top. Biggest tip for 63, put this on a calculator and graph it to help you visualize it. And then if you think that plus 7, we know it's moving it up 7, that's going to affect our horizontal asymptote. And since it goes right 3, that's going to affect my vertical asymptote here. Now, domain and range of an inverse. If you remember finding an inverse, there's a couple steps. First, we remember f of x is the same thing as y. So we'd have y equals 1/3 x plus 2. And then your second step, we need to switch the x and the y and then solve for y. And then what I would do is I would graph both of these, and then that way you can see what your domain and range would be for them. Next one, graphing some logs. If we graph y equals log base 3 of x, you get something that looks like this green line here. And its inverse of log would be exponential, and that would be 3 to the x. So if we graph that blue line, you get something that looks like that. And remember, inverses always reflect over y equals x, so there should be opposites over that red line, y equals x. And your domain and ranges of both of them will also be opposites. So for my green one, your domain, so your most left x value is 0, and it goes all the way to infinity on the right side. And your range goes all the way down, and it goes all the way up. So we can say that is all real numbers or negative infinity to positive infinity. And if we look at your inverse graph, your 3 raised to the x, the domain and range are just going to be flipped because it's the opposite of your log equation. So instead of range being all real numbers, your domain will be all real numbers. And your range is flipped now too. So 0 less than y less than infinity. Remember, range values is y, domain is x. Please use these examples to help you on several of the other ones. I know I skipped several through this packet, but it's because I tried to cover some of the problems that would help you with the other ones. Ask questions, study over the weekend. Good luck on your finals.